Industrial Engineering, SEMM3813. Assalamualaikum and hi. We are from section 5 and 6, group 5J. Today we will present about our Industrial Engineering group project. Our group members is Tanes, Hakim, Akila Fadlina, Akila Natasha, and Nurjihan. Our product is...
Hello everyone. Let us begin with background of the company. Back in 1883, two enterprising young men, John Fraser and David Neff, pioneered the beverage company known as the Singapore and Straits Erected Water Company. After a few years, specifically on 27th of January 1898, the company is being renamed to Fraser and Neff Limited. For your information, the company successfully entered the Malaysian market in 1930 at big cities such as Kuala Lumpur, Melaka, Seremban, Ipoh, and Penang. Until this moment, FNN successfully introduced 20 food and beverages blend in 13 different categories. They also successfully collab with other companies to produce more products in meeting the customer demands. For example, FNN and the Coca-Cola company reached an agreement to collab. Thus, a new name of FNN already have 8 futuristic manufacturing plants, which required 2,600 manpower. The latest manufacturing plant located in Thailand, where it uses fully solar energy to run the factory in order to achieve zero carbon production. For 2020, the company obtained 3.9 billion revenue, separated where FNN Malaysia achieved 2.2 billion revenue and rest come from FNN Thailand, thus obtained a net profit of 410.1 million ringgit. The study is carried out in order to study the production in food and beverages world. Besides, we are also eager to identify how FNN is able to sustain and become one of the popular brand in F&B world. After gone through few series of lectures, we should able to implement industrial engineering knowledge in a particular scenario. In this case study, we also focusing some parts. First, product background, cost to produce and targeted customer. Next, we would like to find out how the company manage project and to determine the critical activities during producing the carbonated drink. Third, we would like to find the company break-even analysis and payback period. Also, we have to use engineering in order to perform suitable analysis to help the discussion.
For project selection, we are focusing more on product, prices, and customer. And based on our research, we found that carbonated drink that produced by FNN company are produced in a two type, which is bottle type and can type. And it also produced in a variety of sizes and flavor. However, our team are focusing more on 1.5 liter bottle. For the price, we found from the FNN website, price in store is for one bottle is 3 ringgit and 25 cent. And we also calculated price based on ingredient that used for one bottle, which is 2 ringgit and 55 cent. For the customer, we want to know how the company manage the demand. The demand on FNN carbonated drink depends on situation. The first one is a demand over capacity. It's happened on a special day when the demand is quite high rather than in normal days. Here are some strategies to meet the demand. First one is by increasing the capacity. The next one is acquiring new equipment. Next, for the capacity of a demand, it's happened due to the cases of COVID-19 that arise. So here is some way to solve the problem. Firstly, we are focusing on marketing, offer the discount, and also increase the demand. Here is the estimated price that we calculated based on ingredient for 1.5 liter bottle. For carbonated water, it only costs 77 cents. For sugar, 50 cents. For grape flavoring, 43 cents. Food coloring, 41 cents. Citric acid, 6 cents. Preservative is 23 cent and 50 cent. So the total up is 2 ringgit and 55 cent. For bottleneck analysis, we already found from YouTube that this company produces 24,000 unit bottle per hour. So the throughput time is 16 minutes per batch and the bottleneck time is 30 minutes per batch. So we know that 1 day operation is 24 batch and one batch is equal to 24,000 unit bottle just now. So the total production for 1 day is 576,000 units. So the process on flowchart for production is water treatment, syrup selection, flavor added, mixing, cool in refrigeration, carbonation, bottle filling and chilling, packaging, and lastly is labeling.
Okay, so for the project management, we do the activities, work breakdown structure, activities or not, and crash course. Okay, so for work breakdown structure, based on our study and also the idea from our team member, we have concluded that the production of FLN carbonated drink have the work of sugar syrup clarification, and then it will break into water treatment, syrup preparation, and then compounding ingredients will break into mixing various ingredients, carbonating product, and also filling product and packaging. And this is the list of activities for the FNN production carbonated drink. So for the first activities, we have water treatment. Next is syrup selection, B. And then C is others ingredient added. And then D is mix in mixing time. E is cool in refrigeration system. F is CO2 is transferred. G is bottle filling and chilling. H is packaging. I is labeling. So from these activities, we can see that these activities is will go one by one after one by one. So the activities on note will after we observe the activities on note will be like this, because the factory already have the machines that will automatically running after each of one activities, which means from A to B to C until the end. So for the crash course, we can see that all the activities listed is all in the total cost. Means that this production of FNN carbonated drink is very efficient. And then um, the highest crash cost that we get is 125 ringgit, which is on activities E, and then the lowest crash cost we get is 50 ringgit, which is on activities H and I.
In this section, we are going to analyze the economic feasibility of the FNN bottled beverage production system. So in this section, we are going to discuss on the break-even analysis and the payback period for the whole carbonated drinks production system. So we are going to start with the break-even analysis. In order to analyze the break-even analysis, we need to find out the total revenue, the total cost of production for the bottled carbonated drinks. We also need to be able to determine the fixed cost, the variable costs, and the price of selling for the carbonated drinks. So from this data, we will use the formulas provided in order to find the break-even analysis and make a chart based on the data that we have, that we can gather using the formulas. So as you can see in the break-even analysis chart, we have a fixed cost of 886,500 ringgit after taking rent, equipment, advertisement, and salary into account, whilst the variable cost is made out of the cost making for one bottle of 1.5 liter carbonated drinks. And the price is the selling price in shop for the bottle itself. So from the graph, we can see that the break-even point for this production system comes at 4.032 million ringgit, and after a production and selling of 1.24 million units, that is the break-even point where the company will not incur any losses, but also not incur any profit. This is where the investment from the company in this production system will be returned. Next. So now we are moving on to the payback rate. For this section, we are going to compare two different production systems to find out which one is going to be the feasible one. Both production systems will give the same output since both will have a same capacity and function. However, we need to find out which production system will be able to meet the customer's demand and market needs based on the project's life. In this case, we are going to use the ALPS carbonated drink machine as our reference point since we are unable to get the exact machine that FNN uses in their factory. So here we have two systems, System A and System B, which has the same initial cost but a different operation cost and different salvage value. So for System A, we have a operation cost of 50,000 ringgit with a gradient of 4,000 ringgit until its project life after 1 year. Meanwhile, System B, we have 40,000 ringgit starting 1 year with a gradient of 3,000 ringgit until the end of its project life. And for System A, we have an 8-year project life in comparison to System B, which has only 6 years. Next. So here we can see the cash flow diagram for both systems, which is just the same for both systems, but with different values and different project life. This is the graphical interpretation of the cash flow that both systems have to compare between the two. Next. So if we calculate the present worth value for both systems, we can see that System B will produce a profit of 32,288.27 ringgit in comparison to System A, which will incur a loss of 30,955.91 ringgit. This is due to the higher operation cost and gradient in comparison to System B, which has a lower cost and lower gradient, even though it has a lower life project. Therefore, based on the calculation done, we can see that the System B will be the system that will be chosen as the project, will return the investment and produce profit by the end of the life project, hence making it very feasible and economical.
And then we need to identify our bottleneck when produce a product. Basically, a bottleneck is a process that require more time compared to the other processes. So when you know your bottleneck, basically you can reduce the time taken for you to produce your product, which will increase your efficiency and reduce your time and cut your costs. According to the activity on notes in project management, all of the process in the production of FNN carbonated beverage are in critical path. Based on the conclusion, we find that there are no slope in all of the processes. So we can say that all of the process need to be done to produce the product. And for the crash cost, the lowest crash cost is at H and I, which are RM 50 ringgits, and the highest is at E, which is RM 135 ringgits. System B will be chosen as at the end of the project. As we know, based on the conclusion, based on the calculation, the profit for System B is RM 32,288 and 27 cents, while for the System A, we will lose about 30,995 ringgit and 91 cents. So we will choose System B as the system will return the investment and produce profit at the end of the project. As a whole conclusion, we can say that FNN is a good company as they have a good production of products. So that's all from us. Thank you so much. Assalamualaikum and bye.